Hi friends, in engineering physics we shall try to understand yet another unit, namely electromagnetic waves and fiber optics. Now currently the most demanding application of engineering is what is known as communication. Now the communication is sent generally in the form of signals from one area to other or from one device to other device. Now these signals can be broadly categorized as two types. One is called analog signals, another is called digital signals. Digital means binary form, analog means wave form, something like this. Digital is something like this. In either case, normally communication happens like this. For example, you want to send in telephone, for example. If you see a telephone or a mobile phone, on one side of a microphone you said hello. Now how this hello will be transferred? For example, you take one telephone device, there is another telephone device. Now these two are connected by means of, let us say, an exchange. This word hello is to be transmitted like this. First thing you have to understand is this hello is nothing but, you can say, it is an information signal. This information signal is to be transmitted through this. To carry this information signal, you need another signal called carrier signal. It is like this. For example, you are going from one place to other. You normally go, let us say, on a bike. So you are sitting on the bike, started driving the bike, reached the destination. Now when you are entering the destination spot, you leave your bike outside the compound or outside the house and you get inside. In that case, you are the information signal, your bike is the carrier signal. So therefore your frequency should match the frequency of your bike, then only your signal, you can be carried out. Like that, if I want to send hello, this is the information signal, I need to generate similar carrier signal, superimpose these two so that together they form like this. So this is the resultant of these two waves getting superimposed. Now it travels. This form of mixing these two, superimposing information signal on carrier signal, is what is called modulation. So you have modulated the signal and this signal gets transported to the other side. From the other side, what should happen? After reaching the destination, this modulated signal, what you represented like this, should split into, again, information signal and carrier signal. Now while reaching the destination, the carrier signal should die out and only information signal should get inside. So that process of again splitting this is what is known as demodulation. So two things are happening, modulation and demodulation. Modulation is a process of superimposing the information signal on the carrier signal so that the resultant become like this. And after reaching the destination, this signal again, modulated signal, is to be demodulated. That means it should be separated into information and carrier signal so that carrier signal dies out and only information signal reaches the destination. So this process is called demodulation. So modulation and demodulation takes place in communication. So the device which does this activity, both modulation and demodulation, is what is termed as modem. You might have heard him on internet. an instrument or a device known as modem. Modem is nothing but a device which performs this modulation as well as demodulation. So this is how information gets carried. But the problem in information carrying is signal loss, which we call as attenuation, and it takes time, and also losses will be there. So how do we save the time as well as signal loss in this? So for that, instead of sending this information in these formats, so entire signal can be sent in the form of a light wave. If you send anything in the form of both sound, audio, video, all types of signals are converted into light signals and transmitted in the form of a light signal. So there are many benefits by sending any signal through these pattern using light waves. That is what light is nothing but an electromagnetic wave. So therefore, electromagnetic waves are nothing but light waves which are a means of communication. So communication is transmitted through carrier waves in any system. So when the frequency of the carrier waves are high, the information carrying capacity also enhances. Because the propagation of light takes place in the form of high frequency waves, these light waves can be used to carry information as carrier waves. So for guiding these information carrying light waves properly, you need a medium. That medium is what is known as fiber optics, which is popularly used nowadays. So we'll come to fiber optics a little bit later. So therefore, we need to understand how do we calculate, how do we understand how information can be processed in the form of a light wave. Because light travels at a higher speed. Now, light, the moment we use the word light wave, it is nothing but an electromagnetic wave. What is electromagnetic mean? When we use the word electromagnetic or EM, what we call, this is a branch of physics in which both electric and magnetic phenomena are studied. That's why it has the name electromagnetic. What it studies, when we say electric, that means it will have charges. So this particular branch EM or electromagnetics, it studies the interaction between electric charges, both when they are at rest as well as when they are in motion, and we will try to understand them by doing some physical interpretation, analyze them, and apply that electric and magnetic fields and see what will happen when they are used as carrier waves. So the principle of, therefore, electromagnetic waves or electromagnetics plays a very important or a vital role in communication, especially with respect to waves like microwaves, let us say antennas, electric machines, satellite communication, radars, optical fibers, etc. In all these areas, electromagnetic waves play a very important. Using these things, some of the devices which we use or come across are. So these are some of the devices where the principle of electromagnetic play a very important role, like transformers, electric relays, radio communication, TV communication, telephonic communication, functioning of electric motors, transmission of electric lines, waveguides, which I shall explain later, antennas, radars, fiber optic technology. These are all various applications. So this is how electromagnetics plays a very important role. Now what we have to know about this? So these are all applications of electromagnetics. For the application of electromagnetic technology, it is essential for us to have some knowledge of various laws and various principles that are involved in these transmissions. That is, To understand the applications of electromagnetic technology, it is essential for all of us to have some basic knowledge of various laws and principles involved in communication. Right? Now, that can be understood in the form of some mathematical notations and mathematical equations and mathematical approaches. So, though the concept name is electromagnetic waves, and thereupon we'll come to the concept of fiber optics, it is very much essential for us to understand, because these communications are required for these type of devices which we come across in day-to-day life. And as engineers, we need to have a basic background about all these things. It is essential, therefore, for us to have a basic understanding of the various physics principles and laws involved in the design of all these devices. That principle or laws are in the form of mathematical approaches. So therefore, now the focus will be on understanding the significance of mathematical part of the physical phenomena. In that, first principle we come across is something known as, what are the field maybe? Maybe an electric field or a magnetic field. But there is a phenomena called divergence. Divergence of a field. So please remember, the word divergence is nothing but a scalar product. Or you can as well call it as a dot product. Now, how do we understand this? Now, if you want to multiply a vector, we use an operator called del. It is represented by this symbol, small delta. This delta used operator with a vector, let us say A. Normally vector is represented like this. So therefore, how do we represent the divergence of a field? Del dot A. If A is a vector. So divergence is a scalar. Suppose you take any field, vector field, this area. Suppose you consider it a point here. How much of flux is diverging from this point? That is, what I am trying is, amount of flux, maybe electric or magnetic, per unit volume. How much amount of flux per unit volume diverging out from that point is what is known as the divergence of this vector field. So therefore, how do we define this? We define this as divergence of a vector field at a point is defined as the amount of flux per unit volume diverging from that point. This is what is known as divergence of the vector field. How do we represent this mathematically? Now consider a vector function A. Let us say it is differentiable. Please remember, I hope by this time you should be familiar with the calculus part, both differentiation as well as integration, because without that physics cannot be understood. Let a vector function A be differentiable at, let us say, x, y, z in a region of space. A be a vector function differentiable at x, y, z in a region of space. Then we can easily find the divergence of A can be, how do you write the divergence of A? Nothing but del dot A. it is represented as, in unit vector form we represent I into dou by dou x plus j into dou by dou y plus k into dou by dou z multiplied by dot product na multiplied by iax plus jay plus kaz. This is how the divergence of a vector function can be denoted using unit vectors, because we are taking a point. Now this, when you simplify, it comes to around simply dou ax by dou x, dou ay by dou y plus dou az by dou z. Clear? So therefore, del dot A you can represent as divergent of A or del dot A. That is nothing but dou ax by dou x, dou ay by dou y plus dou az by dou z. This is how you can represent the divergence. So divergence therefore can be expressed in a coordinate system like this. Clear? So this is one mathematical approach called divergence you have to understand. Then we shall go for another concept called curl of a field. What is curl of a field? The field can be anything. It can be either electric field or a magnetic field. Curl of field is nothing but a property. This property generally is exhibited by the field. For this field, that is for which use the word line integral round of any closed path is non-zero, and it cannot be derived as the gradient of a scalar field. You have come across a term called velocity gradient, etc., in surface tension, etc., in +2 standard. So what is curl of a field? Curl of a field is a property exhibited by the fields. For those fields, the line integral round of any closed path is non-zero, and we cannot derive it as a gradient of a scalar field. What does it mean? Now from this, we shall try to define what is meant by curl of a field. Curl of a field can be defined as the maximum line integral of the vector per unit area. Simple definition. Curl of a field is the maximum line integral of the vector per unit area. When I say vector, it's a vector quantity. Divergence is a scalar, curl is a vector. When we say vector quantity, we also, apart from magnitude, we need to know the direction. Direction is always normal to the area. That is perpendicular to the area. That is the direction of curl. Now, how do we represent this mathematically? Now, let us say as taken earlier, let us take A is a function. This function is differentiable at x, y, z coordinates in space. Then curl, if you want to represent, it is a cross product. If divergence is a scalar product, that is dot product, curl is nothing but a cross product. Now, how do we represent this? That means you can represent it as a matrix. Try to recollect fundamentals of dot product and cross product from your intermediate understanding or plus 2 understanding when you studied about elements of vectors. The scalar products are always called dot product properties as well as cross product or vector product properties. So therefore, this can be understood as curl A is equal to del cross A. It's not del dot A, it is del cross A. That means you can represent this into ijk as a matrix. Now you have dou by dou x, dou by dou y, dou by dou z, and you have ax, ay, az. This is how expression for curl in a coordinate system can be represented. Based on this, we will try to understand a concept called Stokes Theorem. What does it say? For curl, the Stokes Theorem says that you use the word line integral. Na? So therefore, line integral of a vector field, let us say A, where it is around a closed curve. Line integral of a vector field around a closed curve is equal to the surface integral of the curl of A taken over the surface S surrounded by the closed curve. This is what Stokes theorem talks about. The line integral of a vector field around a closed curve is equal to the surface integral of the curl of A taken over the entire surface surrounded by the closed curve. So this is what Stokes theorem statement talks about. Now if you see the mathematical expression for this closed curl, a small area length, that is equal to double integral of the surface curl A dot ds. Now this is equal to double integral S del cross A. Instead of this I can write del cross A ds. This is a mathematical representation of Stokes theorem. Now we shall try to elaborate this theorem to understand further and interpret some important points from this for present discussion. We'll consider a surface S enclosed in a vector field. At a point, for example, this is the direction of the tangent. So you are taking the vector point. A small area element you can take, let us say ds. So you are considering a surface S enclosed in a vector field A in which a closed curve xyz represent the boundary surface. Closed curve xyz means I am elaborating this. So at a point if I take, I am taking all the three directions. Now this is the curl. Now any area you take, that is infinitesimally small area you are taking. infinitely small. That is what we call as infinitesimal. So in this area, if you take the line integral of A around the curl, so line integral of A around curve xyz, this is y, this is x, this is z. What is the line integral of A around xyz? We represent as closed curve A dot dl. Right? Now what you need is the entire surface of S. You divide this into large number of square loops. So when I divide this into large number of square loops, let us say like that. So this is rotating like this. So I have divided the entire surface S into large number of square loops. In that I am considering a small area ds. ds is nothing but, this is nothing but a small area inside here. So I am dividing the entire surface S into large number of square loops. Now ds is an area enclosed by each small loop. Right? So when you draw an outward normal, I am talking about unit positive outward normal on small ds. Let this be unit vector n. Then this is outward normal unit vector n. Right? Then what is the vector area of the element in that case? The vector area of the element is nothing but nds. Unit vector you are taking, therefore this is ds. Now we know that the curl of a vector field at any point is the maximum line integral of the vector computed per unit area along with the boundary of the infinitesimal area at the point. So therefore, that case the line integral of A around the boundary of ds, what is that? Curl A ds. Right? Now it is applied to all, it is one element. You can apply this to all surface element. Therefore, when you apply to all surface elements, sum of line integrals will become what? Sum of all line integrals of A around the boundaries of all the area elements can be curl A dot ds, which is the surface integral of A. So from the figure, if you see, we can understand that the line integrals along the common sides of a continuous elements mutually cancel each other, which are traveling in the opposite direction. So therefore the sides of the elements which lie in the closed curve of the surface contribute to the line integral. So they are which are traveling in the opposite direction, they are getting cancelled. The sides of those elements which are lying in the closed curve of the surface contribute to the line integral. So therefore, this equation gives the sum of line integrals of the boundary line of the curve. That means A dot dl is equal to curl A ds, that is equal to del cross A ds. Now this equation is what is known as Stokes theorem. This is nothing but a method. That is, Stokes theorem is a method to convert a surface integral into a line integral and a line integral into surface integral, vice versa. Both ways. You can convert a surface integral into a line integral, and also you can convert a line integral into a surface integral. This is what Stokes theorem is all about. It is about curl. That is a vector. Similarly, for divergence, we use another concept called Gauss theorem. Gauss theorem is for divergence. Stokes theorem is for curl. So we shall try to understand the divergence method with respect to Gauss theorem, how Gauss theorem can be applied for divergence in the next section. This is about Stokes theorem. So practice this Stokes theorem because we have the application of Stokes theorem. So in the next session, we shall try to understand the next mathematical approach with respect to divergence in the form of Gauss theorem. That is in the next session.